Hi everyone, in this video we're going to continue on with section 6.5, which is about using properties of logarithms to help us solve various problems. In the last video we ended with using our logarithmic properties that we know to write or express a single logarithm as a sum or difference of different logarithms while expressing all powers as factors. And so we did an example and went through a your turn, but I wanted to begin this one with another example just to get our minds fresh. And this is a little bit of a challenging example, so I wanted to go through and make sure that we see something a little bit more challenging. So the first thing that I see that I can do is that I've got a log of a quotient. And I can express the log of a quotient as the difference of the logs. And so I can rewrite it as log base A of the square root of x squared plus 1 minus log base A of x cubed times x plus 1 to the fourth power. And so now I've expressed the log of a quotient as the difference of logs. The next thing that I want to do is notice that in the second log, in my difference, this one right here, I've actually got a product, x cubed times x plus 1 to the fourth power. And so I can rewrite that as the sum of logs, because if you remember, the log of a product is equal to the sum of the logs. So I can rewrite, I'll keep the first one the same, log base A of the square root of x squared plus 1 minus the quantity log base A of x cubed plus log base A of x plus 1 raised to the fourth power. Okay, I've got a lot of parentheses going on there, but it's important to keep in mind that the negative here, this negative, goes to both the first and to the second terms. And so if I distribute that negative through, I've got log base A of the square root of x squared plus 1 minus log base A of x cubed minus, again, log base A of x plus 1 raised to the fourth power. And the last thing that I need to do is express all powers as factors. And what that means is if any of the arguments or any of the terms that are either multiplied or any of the terms that have an exponent on them, I can bring them to the front. Okay, and that's not true always, only when the exponent applies to the whole thing inside the logarithm. And I'll show you what I mean in just a second. So the first thing that I need to understand or recognize is that the square root is really something raised to the 1/2 power. And so really it's x squared plus 1 raised to the 1/2 power in that first term. So what I can do is bring the 1/2 out in front, and I get 1/2 times log base A of x squared plus 1 minus 3 log base A of x, again because the 3 was the exponent, so I could bring that down in front to express it as a factor, minus 4 log base A of x plus 1. Okay, again bringing down the 4 power to factor. All right, and so that turns out to be the final answer. The sticking point for some people is you might say, well, I have to do something with this x plus 1, and I have to do this, and I have to do something with this, and there's an x squared there, and so can the 2 come out? And the answer is no. If I have things that are added or subtracted together inside a log, I can't do anything with it. If they're multiplied or divided, then I can do something. But if it's adding and subtracting, I can't really do anything there. Okay? So that's the final answer. Now, let's move on to another skill. If I can rewrite the log of something nasty inside as the sum or difference of logs, I can, in fact, work backwards. And I can rewrite the sum or difference of logs as one single logarithm. And so that's what I want to do here. I'll call this, come back here. I want to call the left one number 1 and the right one number 2. And we're going to use the same exact rules that we used in the last couple slides, but just backwards or in reverse, or however you want to think about it. So if I look at number 1, I've got log base a of 7 plus 4 log base a of 3. What I want to do is express it as one single logarithm, so log base a of something. And the last step that we did in the previous slide was to express all powers as factors, or equivalently bring any exponent down in front of the log. If we can do that, we can go backwards as well. And so we can take this 4 and put it as an exponent on the 3. And so I could rewrite this as log base a of 7 plus log base a of 3 raised to the 4th power. And 3 to the 4th power is 81, so I could rewrite this as log base a of 7 plus log base a of 81. And now I have a sum of 2 logs with the same base, and in all of these cases, they need to have the same base in order to manipulate them. If they don't have the same base, I can't do anything with them. But here, of course, they do. So if they do, I have 2 logs, same base. If I add them, then I could rewrite that as one single log term if I multiply the things inside the log. And so I could rewrite this as log base a of 7 times 81. Okay? And if you do the multiplication, you get log base a of 567, I believe. And so now I've rewritten number 1, log base a of 7 plus 4 log base a of 3 as one single logarithm. And so if I give you an example where it's all numbers and no variables, then there's going to be a good chance that some things are going to combine, or that you can do some manipulation with them. Such as here, I multiplied 781 to get 567, so I can simplify like that. If we move on to number 2, it's the same sort of premise, but the only difference here is that I have actual variables and not just numbers. And so when I have variables, it's less likely that I can combine things down to, say, one number. So I'm going to have variables in there. They're going to stay. We just need to figure out how exactly to work with them. So instead of viewing this as the sum of 4 logs, we can split it up into parts. And so what I mean by that is I only first want to look at the first 2 terms. I just want to do log base a of x plus log base a of 9. Just as before, if I have the sum of 2 logs is equal to the log of a product, or log of the product of the inner of the things inside the logs. And so I can rewrite log base a of x plus log base a of 9 as, I keep exiting out. I'm again looking at these first 2 terms, and sorry if everything else got erased, 1 and number 2. Log base a of x plus log base a of 9 is equal to log base a of 9 times x, or 9x. So all that I did was apply that property that the sum of logs is equal to the log of the product. Right? And so now I have that. I'm going to bring down the other two terms because I haven't done anything with them yet, plus log base a of x squared plus 1 minus log base a of 5. All right, so now I have that. And again, I just want to look at the first two terms. Log base a of 9x plus log base a of x squared plus 1. Again, I just have the sum of two logs, so I can combine them and see the log of the product. So I have log base a of 9x times x squared plus 1 minus log base a of 5. I just multiplied the things inside. Again, there's no sort of simplification because I have variables. Of course, if you wanted to, you could do 9x times x squared and 9x times 1, and we'll do that in just a second, but that's not really important right now. The last thing that we need is to get rid of this minus log base a of 5. Now, when I have the difference of two logs, it becomes the log of the quotient, which means I'm going to divide the two things inside the logs, meaning 9x times x squared plus 1 and 5. So the new and sort of final answer is log base a of 9x times x squared plus 1 divided by 5. Okay, and of course you could, if you wanted to, distribute the 9x, but it's not really important. So to practice these skills, here's a your turn. Right, so this is of course, a logarithmic expression. It's got all numbers, so just simplify as you can and combine into one single logarithm.